Factoring trinomials. If you recall from the first lesson in this section, we had trinomials where we had ax squared plus bx plus c, where a was always 1. So there was always a 1 here in place of the a. Today we're going to do this where a is some other number. And that complicates things because when we're looking at foiling and distributing, we know that we have to multiply the outside and the inside to find that middle term, so whether we add them together. Now we have to take into account that there's going to be some other number in front here that we have to multiply by because it's no longer a 1. And that there may be a number here as well that we're going to have to multiply by besides 1. So this pattern that we've been doing kind of no longer works because we have to take into account now this 2, for instance, in this problem. So we're going to still factor this into 2 binomials. But what you need to recognize is that x squared is not going to just be x and x. It's going to be x and x, but there's going to be some numbers in front of those x's now because we have factors of 2 that will give us 2x squared. Well, in this case, 2 is prime, so it's only 2 and 1. So now we know that's going to be 2x and 1x there. And then we look at the factors of 5. So we looked at 2, which is 1 and 2. 5 is only 1 and 5. So in this case, this isn't too bad because both factors are prime and we can only use 2 and 1 and 5 and 1. So the question becomes then, where do we put the 5 and the 1 in order to get the 7 in the middle? And this is factoring when a, b, and c are positive. So when this is positive, we know we're going to have to add the factors together to get that middle term that we're looking for here of 7. So we're going to add to get 7, and since that's positive 7, we know it's going to be adding in both and not subtracting or not minus. And so how can we add the 2 numbers here? Where can we put the 5? We need to put the 5 and the 1 here and here, and these are both going to be plus, so that we get 7. Well, if we put the 5 here, then we're going to get 10 right away, and that's already bigger than 7. So we know the 5 can't go there. So we need to put the 1 there and the 5 here. And so let's just check this quickly then. 2x times 1 is 2x. That's the outside. And the inside is 5x times 1, which is 5x. Do 2x plus 5x give us 7x? Yes, they do. Okay. And we check the first and last. 2x times x, 1x, is 2x squared, and 5 times 1 is 5. So we know we got them in the right place. You should always check by foiling whatever you get. So our answer to this is 2x plus 5 and x plus 1. And notice I left off this 1 right here. And that's okay because we know that in front of any variable that doesn't have a number in front of it, there's a 1. So next is factoring when b is negative and c is positive. So if this is positive, we know we're still going to have to add things together, but those things have to be negative because the only way to add things together and get a negative is if both of them are negative. So we're going to take this factors, and we know that both of these are going to be negative here. And now we have to look at the 6 and the 3. So 6 has factors of 6 and 1. And it has factors of 2 and 3. So we don't know yet whether this is going to be 6x and 1x or 2x and 3x. So I'm just going to put the x's in there because we don't know what's in front of them yet. And then I'm going to look at the other number. Well, 3 is nice because it's prime. So 3 only has factors of 1 and 3. So I'm going to put the 3 and the 1 in here. And then I'm going to figure out whether we're using 6 and 1 or whether we're using 2 and 3. And the way we do that is we test these. So if we put 6 in here and 1 in here, does that give us negative 11 when we add those together, the outside and the inside term? Well, this is a negative 18x. This is a negative 1x. So no, that doesn't work because that's going to be a negative 19x and we want negative 11x. What if I put the 1 and the 6, replace the 1 and 6 the other direction? So I'm going to pull these 1 and 6 out, and I'm going to put the 1 here and the 6 here. So now what happens? So now I have a negative 3x and I have a negative 6x. Is that negative 11x? No. So the 6 and 1 don't work. Now, I'm going to show you over here really what we're doing. We're trying 6 times 3 and 1 times 1, which is 18 plus 1, which is going to be 19. And it's going to be negative because really those are all negative numbers we're talking about there. And then I tried the 1 with the 3 and the 6 with the 1. So 6 times 1 plus 3 times 1. And that gave us 6 plus 3, which was 9. And so that's not enough. So we know those won't work. So now let's try the 2 and the 3 with the 1 and the 3. So if I go 2 times 1 and 3 times 3, is that going to give me 11? Well, 2 times 1 is 2, and 3 times 3 is 9. Look at there, I got 11. So there's the 11 that I was looking for in the middle. So I know I'm going to have to multiply this 2 times a 1, and so I'm going to have to multiply the 3 by the 3. So how can I do that in my first outside, inside, last? Let's erase this and start so you can see it clearly. If you remember, I have in here an x and an x, and then I have the 3. Actually, I think I put the 1 first. The 1 and the 3, and minus and minus. And then I said I have to multiply a 3 by a 3 here. So this 3 has to get multiplied by a 3 out here. And this 2 has to get multiplied by a 1. So the 2 has to be multiplied by the 1. There are many times when trial and error is the only method that works here. But if you can set up these factors and look at the different multiplications this way, sometimes it's easier. If not, all you can do is try the numbers in every form and see which one works. So the answer to this one is 3x minus 1 and 2x minus 3. Factoring when c is negative. When c is negative, we have a little bit different problem because that means you're going to subtract the factors. So when c is negative, you're going to have to subtract the factors. So again, we're going to set up our binomials. And again, the 3 is easy because the only factors of 3 are 3 and 1. But 4 has factors of 4 and 1 or 2 and 2. And again, we know this is going to be x, and this is going to be x, but we don't know whether it's going to be plus and minus or minus and plus. But we do know the signs have to be different because we're going to subtract them. So that might be a plus 1 and a minus 3, or it might be a minus 1 and a plus 3. So all we do is try numbers in here. Well, if you put 4 here, that's going to multiply by 3, and that's going to give you 12. So right away we can say that's 12, and then this is going to give you 1. That's going to be 12 minus 1. And we know that's not big enough. That's too big for 4x. So now let's try 1 and 4. If we put the 1 here and the 4 here, then that's going to give you 3x and 4x. And we have to subtract those, so that's going to give you a 1x. So we know it can't be that. So now let's try the 2 and the 2. So 2 times 3, 2x times 3 is 6x, and 1x times 2x is 2x. And when you subtract those, you get to the 4 we're looking for. Then the problem becomes, which one of those is negative? Is the 6x negative, or is the 2x negative? Well, if we took 6x minus 2x, that would be positive 4x. But if we take negative 6x and positive 2x, then we're going to get a negative 4x. And we want the positive 4x, so this has to be a positive 6, and this has to be a negative 2. So determining which one is the last step here. So this has to be a negative 2x. So here's my 2x right here. That's going to be negative, and my 6x is going to be positive. And again, you should always check these. 2x times 2x is 4x squared. 2x times 3 is plus 6x. Negative 1 times 2x is negative 2x. That gives us, when we subtract those, that gives us this positive 4. x, and then negative 1 times positive 3 is negative 3. So 2x minus 1 and 2x plus 3 is your answer. So, another one. And again, talk yourselves through these. So we know that 3, and we're looking at the 3 and the 4 here. We know that 3 is prime and 4 is not, so we're going to have to use 3 and 1, and we could use 4 and 1 or 2 and 2. We don't know which ones we're going to use of the second pair. But we do know that we're going to subtract them, and that the bigger of those subtraction problems has to be the negative, because we need a negative 11 in there. So let's put in what we do know. We know 3x and 1x, because 3 and 1 are the only factors of 3. We don't know which plus and minus. We know plus and minus, but we don't know which one goes where. And so now we have to try the 2's and the 4's. And 11 is a pretty big number, so I'm going to have to multiply something that is going to be a little bit bigger number, and I'm going to subtract something from it to get 11, since I'm subtracting. So if you look at these pairs here, well, right away I see this. 3 times 4 is 12. So let's try that one. And then that would be 1 and 1. So here's the 3 and the 4 and the 1 and the 1. And so 3x times 4 is 12x. And 1x times 1 is 1x. And we're going to subtract those. Does that give us 11x? Well, yes, it does. But when we do it this way, we get positive 11x, and we need negative 11x, so we need to have the 12 be negative. So if the 12 is going to be negative, then the 3x times the 4 has to be negative, and the 1x times 1 has to be positive. So 3x plus 1 times x minus 4. Factoring with two variables. So again, we have two variables here. So we have our x's and we have our y's. And notice I left space in front of the x's and space in front of the y's so that we can put the numbers in there. This is a positive, so that means we're going to add the factors together. And since that's a positive and this is a negative, they have to both be negative. So it's much easier if you can determine right away what sign it is, and you can do that if it's a plus before the C there. So now let's look at our factors. Well, 2 only has 2 and 1. 5 only has 5 and 1, but we have to figure out which order they go in. So in order to get 11, I'm probably going to have to times 2 times 5, because that's 10, and 1 times 1. So I'm going to put the 1 here and the 5 here. And then let's check that. 2x times x is 2x squared. So I did the first. The outside 2x times negative 5y is negative 10xy. And on the inside I have a negative 1y times 1x, which is a negative xy. So 10xy minus, and if you want to, you can put the 1 in there, minus 1xy is 11, and negative 11xy, because negative 10 and negative 1 is negative 11. So there's our middle term. And then negative 5y times negative 1y is negative 5y squared. So this is indeed correct, 2x minus y and x minus 5y. Rearranging before factoring. Again, if you remember from the last lesson, these need to be in a particular order in order to do this factoring. And we always need them in descending order according to the variable. So I'm just going to rearrange these. Here's my x squared, here's my x, here's my 5. So 12x squared minus 17x plus 5. Then I'm going to factor it into two binomials. And again, the 5's here, 5 and 1. That's the easiest one. Oops, 5 and 1. Because we know that's going to be a 5 and 1. We know that this is going to be addition. And we know that we're going to add two negatives. So I can put those negatives right in there. I know this is going to be x and x, but now 12 has a whole bunch of factors. So I could use 12 and 1. I could use 2 and 6. I could use 3 and 4. And we're looking for 17. So what we want to look for here is what numbers, when we add something to them, will give us 17. Well, I know that 5 and 12 is 17, so I bet this is going to be a 1, and this is going to be a 12. So you need to start thinking about which numbers will add up to 17 when you put them in here. And so I know that 6 times 5 is 30, and then 2 would be 32. I know that 2 times 5 is 10, and 6 would be 16. I know that 3 times 5 is 15, and then plus 4 is 20. And I know that 5 times 4 is 20, plus 3 is 23. So just going through in your head and multiplying those factors out with 5 and 1 can help you decide which ones work. And so let's check this. 12x times 1x is 12x squared. This is 12x times negative 1 is negative 12x. That's the outside. Inside, negative 5 times 1x is negative 5x. And when you add those together, you get negative 17x. And then negative 5 times negative 1 is positive 5. So it is indeed 12x minus 5 times x minus 1. One more problem. Again, let's put them in the proper order. So the 4x squared comes first, and then the negative 7x, and don't forget to take the sign with the number, and then the negative 2. And again, we're going to factor this. And so I'm going to try 2 and 1 because that one's prime. So we know that they're going to be subtracted. This tells you subtracted. And the larger one has to be negative because that answer right there has to be negative. Okay, so let's try 4 and 1 and 2 and 2. Okay, so I know these are going to be x's. So 4 and 1. And you can do this over here this way too if you want. If I multiply 4 times 2, that's 8. Minus 1 is 7. Oh, look at that right there. So the first one I came to, I got 8 and 7, and I'm going to subtract those. So again, which one has to be negative? If I'm going to have 8x, here's my 8x outside, here's my 1x inside. And I'm going to subtract those. 8x minus 1x would be 7, but I don't want positive 7. I want negative 7, so that has to be a negative 8x. So this term has to be negative. This one has to be positive. So 4x plus 1 and x minus 2.